Okay, so far to this point, we have solved quadratics by factoring. And we saw within that a little bit of some of our factoring gives us a perfect square. And so something like x minus 2 squared equals 0. And we write out separate, or I did mention being able to take the square root of that. So now in this section 9.1, we're going to focus on solving equations by taking the square root. So our essential question is, how can you solve quadratic equations using square roots? We know a little bit of that already. We're going to go in more detail from here. So a quick little review, finding the square roots of just numbers. We've done this in the past. Remember, what we want to do is we want to do our factor tree. So 49 breaks down to 7 and 7, and then that's our pair, and so the square root of 49 is 7. With the fractions, remember, we can split it up as the square root of 16 over the square root of 100. Deal with each of those separately. If you break down 16, you get 4 and 4. Some of you guys just know that square root of 16 is 4, and square root of 100 is 10. So we get 4 over 10, or 2 over 5. Now 12 isn't a perfect square, so we need to really break that one down. So we get 4 and 3. 4 breaks down to 2 and 2. There's my pair that I can pull out. So I get 2 square root, and that 3 is left on the inside. Now this 0.27, we've done a little bit where we can rewrite that as a fraction. So 0.27, this is the tenths place, this is the hundredths place. So you get 27 over 100, all under the square root. And we know that square root of 100 is 10, but 27 we need to break down. And that gives us 9 and 3. And 9 is 3 and 3. So there's my pair. And so I get 3 with a square root 3 left. Okay, quick little discussion. So what I want you to do is write down your ideas. Explain why a must be non-negative when you find the square root of a. And the second one is, does 0 have any square roots? Why or why not? Okay, so answer those questions, and we'll discuss those when we come back into class. Alright, so example 1, we want to solve the equation, give the answer in radical form, and then use a calculator to approximate the solution to 2 decimal places if necessary. Okay, so as we work through this, we're essentially doing what we've done before and solving for x. And so this time, we want to get our squared term by itself. Okay, so our first step is isolate squared term. So in this case, we would divide by 3, and you get x squared equals 16. Then once you've isolated the squared term, you're going to take the square root. So square root, and we get x equals 4. And really the answer here is going to be plus or minus 4. Which I will go into detail in a little bit of why it is plus or minus. Alright, so on the second example here, we have a little more work. So we want to work backwards to get our x squared term by itself. And so in order to do that, what we're going to do is we're going to add 5. And you get 4x squared equals 7. Divide by 4. And you get x squared equals 7/4. Take square root of both sides. And you get x equals Square root of 7 is just the square root of 7. Square root of 4 is 2. And then we are plus or minus. Alright, so what I want you to do is work on these 3 problems. So go ahead and pause now so that you can work through these problems on your own. Alright, so first one here, we're going to add 8. And you get 2x squared equals 8. Divide by 2. And x squared equals 4. Take square root, and x equals plus or minus 2. Alright, so on number 2, some of you may see right away, and you could have done on number 1, factor out GCF, and then solve from there. This one, some of you might see is difference of squares, so 3x and 4. 3x and 4, one positive, one negative, set it equal to 0, and then you can solve. So some of these that you can solve by taking the square root, you can also solve by factoring, and later on down the road we will deal and specifically talk about which one is better to do at which times. For right now we're just going to focus on square roots, even though we could use difference of squares to factor it. So we're going to add 16. And we get 9x squared equals 16. Divide by 9. And x squared equals 16 over 9. We take the square root. And x equals 4 over 3 plus or minus. And last one. Okay, and last one here, we're going to add 9. And we get 5g squared equals 11. Divide by 5. And g squared equals 11 over 5. We're going to take square root. And g equals plus or minus the square root of 11 over 5, since the square root of 11 is just the square root of 11, and the square root of 5 is just the square root of 5. Alright, so discussion. When is it best to solve by square root? So it is best to solve by square root when we look at our standard form, which is ax squared plus bx plus c. So it is best to solve when there is no b term. Okay, which means all we have is a squared term and maybe a constant. So then the next question, which I alluded to a little bit earlier, is why is there a plus or minus when solving by square root? So a couple things we got to think of is, let's start with this simple case. So we have x squared equals 9. So when I take the square root of that, we would write x equals 3 normally, because the square root of 9 is 3. But when we are substituting that back in, 3 squared equals 9. But negative 3 squared also equals 9. And so both of those are solutions that can work. And because what's really happening here is when you are squaring something, that always makes it positive, because a positive, like 3 times a positive 3, becomes positive 9, and a negative 3 times a negative 3 becomes positive 9. So when we square root this x squared, what really is happening is you get x, but not just x, you get the absolute value of x, because we have to ensure that that x value is positive now, because we've removed the squared term by doing the square root, and those canceled each other out. And so this x was positive because we squared it, which means we need to ensure that it's still positive here. So then when we go 9 and we square root it, we get 3. And then when you are solving with an absolute value, the way you do that is you go x equals, and then you go plus or minus 3. And so that's why we get the plus or minus when we are solving only. Alright, so solving ax plus b squared equals c. So on this one we talked about how it is best to solve this when there is no bx. Notice that this x here we have just a squared term. So this is essentially one big x, ax squared is what we're going to do there. And so with that, we want to solving a quadratic equation may involve isolating the squared term, which in this case our squared term is a set of parentheses, of a quadratic expression on one side of the equation first. So over here, let's say we were doing that, what we would do is we divide by that a value, whatever that may be, and you get c over a. Now that may work out to a fraction, may work out to an integer, and then from there we can take the square root. So now as you look at this, we're going to solve the equation just like we did before. Now, as I look at example 1, I have x plus 5 squared. So I have a squared term, which is this x plus 5, and this x plus 5 is isolated, which means we can then go ahead and take the square root. And so then we get x plus 5 equals plus or minus 6. Now, to solve, we're going to subtract 5 essentially, but I have two numbers there. I have a positive 6 and negative 6. So to do this properly, what we're going to do is we're going to set up two equations where we get x plus 5 equals 6 and x plus 5 equals negative 6. Subtract 5 and x equals 1. Subtract 5 and x equals negative 11. Okay, so example 2, our squared term, which is our x minus 5, is not isolated because there's a 3 outside of it. So what we would do on this one is we're going to divide by 3 first, and we get x minus 5 squared equals 6. Then we take the square root, and we get x minus 5 equals plus or minus square root of 6, because square root of 6 can't be broken down. We just leave it as such. And then since we're solving here, we're going to add 5. And this time, since square root of 6 is not a like term with 5, we get x equals 5 plus or minus the square root of 6. And there's no need to write it separate because we can't combine 5 with the square root of 6 like we did in the first example to give us 1 and negative 11. And so this ends up being your final answer on this. Alright, so a little practice for you, so go ahead and pause and work through these problems on your own. Alright, so working through this, hopefully you're able to work through this. Here we need to isolate, so we're going to divide by 4. And x plus 10 squared equals 6. Take square root, and we get x plus 10 equals the plus or minus root 6, and square root of 6 is not simplifiable, so we leave that as. We subtract 10 here. Those are not like terms, so you get x equals negative 10 plus or minus the square root of 6, and that would be your final answer. Now as we move over to number 4 here, our squared term is isolated. So we can go ahead and take the square root, and that gives us x minus 9 equals plus or minus 8. Since the square root of 64 is 8. And then since we have an integer, we're going to be able to combine those. So you can write two equations, x minus 9 equals 8, and x minus 9 equals negative 8. Add that 9, and we get x equals 17. Add 9, and x equals 1. Now, some of you will get in the habit and write x equals, add that 9 over, and then plus or minus 8, which is totally okay. Just make sure you simplify that one step further, and you go 9 plus 8, which is 17, and 9 minus 8, which is 1. We don't want to leave that as our answer because that's not fully simplified, because the correct answer is x equals 17 and 1. Down here on our example there, we could leave that like that because root 6 and 10 are not like terms and we cannot combine those. Alright, so reflection, I want you to find the solutions, if any, for this one here, and then I want you to explain your reasoning why there is a solution and what it is, or why there's not a solution. And we will discuss this one when we come into class. Alright, so we're problem solving equation models by using square roots. So what we have here is a contractor is building a fenced in playground at a daycare. The playground will be rectangular with its width equal to half its length. The total area will be 5,000 square feet. Determine how many feet of fencing the contractor will use. So let's draw a quick diagram of this. So we know that we have a rectangle, and in that rectangle we know that the width is equal to half the length. So our width is equal to 1/2 the length. So if this is our width and this is our length, we can replace our width with 1/2 L. That way we can have same variables, makes it easier to solve. So our width on this rectangle is just 1/2 of L. So then to find the area, we just multiply. So we have L times 1/2 L, and that has to equal total area of 5,000. Well, L times L is L squared, so you get 1/2 L squared equals 5,000. And then from here, we want to isolate our squared term, so we multiply by 2 over 1. That cancels that out. Over here, we multiply by 2 over 1, which is just 2. And we get L squared equals 10,000. And then we want to take the square root, and that leaves us with L equals 100. But we got to pay attention to what the question was asking. And the question states, determine how many feet of fencing the contractor will use. So what we found is one length. And so we need to figure out what the width is. And since the width is 1/2 of our length, so this is going to be 100 for the length. That means our width is going to be half of that, which is going to be 50. And so total we have the opposite sides. So when we add up that amount, which is essentially your perimeter, we get 100 plus 50 plus 100 plus 50 is going to be 300 feet of fence. the example for you. We got the square root of 10,000 was 100. Should have been plus or minus. I was jumping the gun and forgot to say it. We can't have a negative length, so then the only one that does matter is the positive 100. Alright, so a practice problem here for you. So go ahead and work on this one. Pause so you have time to do the problem. Alright, so on this one we have a zookeeper is buying a fence to enclose a pen at the zoo. The pen is an isosceles right triangle. So let's draw that. Since isosceles, we know that those two legs are congruent or equal. There is already fencing along the hypotenuse, so we already have fencing here. The area of the pen will be 4,500 square feet. And the zookeeper can buy fencing the whole feet only. How many feet of fencing should he buy? So we know that the area of a triangle is 1/2 base times height. And so this is our height, this becomes our base. Now in this case we don't know what our height is, so we'll call that x. The nice thing about this problem is since this is an isosceles triangle, if our height is x, our base is also x because those two side lengths are congruent or equal. So that simplifies our problem here, and we get our area, which is 4,500, equals 1/2 x times x, which is 4,500, equals 1/2 x squared. And then what we want to do from there is isolate our squared term. So we're multiply by 2 on both sides, and we get 9,000 equals x squared. Take our square root, and we get x equals the square root of 9,000, which isn't a whole number. So when we plug that into the calculator, we get 94.87, and that is plus or minus. And now we got to put this into context of our problem. Can we have a negative length of fence? The answer to that is no, which then means x can only equal the positive version, but then he can only buy feet and whole feet, so then we would say that he would need to buy 95 feet. And then also remember that x just represents one side length, so he would have to buy 95 feet for each. So he'd do that twice, so when we multiply that, he would have to buy 190 feet of fence. Okay, so this reminds. Alright, so I want you to elaborate here. So how many real solutions does x squared equal negative 25 have? And suppose the function h of t equals negative 16t squared plus 20 models the height in feet of an object after t seconds. If the final height is given as 2 feet, explain why there is only one reasonable solution for the time it takes the object to fall. So I want you to work on those, and we will discuss those when you come back to class. And our essential question is, what steps would you take to solve the equation 6x squared minus 54 equals 42? So I want you to go ahead and you may have to work it out in order to solve it. Some of you may not, but I want written steps of how you would solve this, exactly, specifically what you would do. And we will share this out when we get back into class. And then for those of you who want to get a head start on the homework, here is your assignment for 9.1.